Assalamu alaikum friends, my name is Bilal Khan and this is my 24th video of DevOps. So in this video I am going to talk about labels and selectors. So the labels are attached to an object. It can be any object and the labels are attached to it and it will identify that object. Alright, while the selector selects an object to fetch it with the help of commands. Alright, so the label is used for identification and the selector is used to select an object. Labels are the mechanism you use to organize the Kubernetes objects. Alright, so it will organize the Kubernetes objects. A label is a key value pair without any predefined meaning that can be attached to any object, not just pod but node also. Alright, so it is not something that is already predefined. It can be attached to any object and it is not just limited to node or pod. It can be attached to any object. Alright, it is used for quick reference. So if you want to reference something, you will use the label. Alright, so you are free to choose label as you need it to refer an environment which is used for development, testing and production. Alright, refer a product group like development A, development B and company C, etc. And multiple labels can be added to a single object. Alright, so as per requirement, in one object, multiple labels can be used. Alright. So there are two methods for writing a label. The first one is the declarative method and the second one is the imperative method. So let's look at the first method. The declarative method, you can write a label inside your manifest file. This is the declarative method. So this is an example of declarative method in which you can write your labels inside the file. Manifest file. So let's take a look. Let's first of all copy this, and before copying this, let's check it. Does I have already this file? Yes, maybe. Cat pod 1.yaml. Alright, so I have already this file present here. Basically, I have copied this data into this pod1.yaml file. So there is no need to copy this data. So what I will do, basically I will first of all start the minikube. Let's start it, and before starting it is giving me a some error. Let's write it again. Minikube start driver is equal to Docker. Alright, so now maybe it is. Let's see what is the problem here. Socket. Let's write it with permission. Sudo. Let's check it out. It is again giving me the error. Now as you can see that I have followed the suggestion and now it is running. It is going to run. So let's wait for it. It will take some time. Now this is done. The kubectl is now configured. So let's clear this and write minikube status. If I write status, it will show me the running status that the host kubelet API server is running. So let's clear this, and after that I have already copied the data. So now let's move into the command that I will be using here. So let's open this and paste it. Let's drag it down. And after creating a pod, it means after writing this data inside the file, apply it in kubectl by writing kubectl apply fpod1.yaml, as you know that the data is present inside the pod1.yaml file, and I'm going to apply it. So let's click on this. As you can see that this will show me that the test pod is created. So how will I know? I will simply write kubectl in this command. I will write kubectl get pods show labels. Alright. So as you can see that currently this pod is already created, and now I have created this new pod that is by the name of test pod. Alright. So these are the two pods that are currently running. So after that, the next method is the imperative method. So if you want to add a label to an existing pod without updating the manifest file. Alright, so in the previous method we were giving a label inside the manifest file, but in the imperative method we are going to add a label without using the update manifest file, but we will use it in the terminal. Then type in the terminal kubectl label pods. So let's take a look at this. But kubectl label pods, and the pod name would be, let's say, test pod. Alright, so we are going another pod label to this test pod. So let's drag it, and now you can see it clearly that currently this test pod has currently two labels. The first one is the class pod, and the second one is the development pod that I have shown in the manifest file. As you can see that these are the labels: environment, key, and the development is the value, class is the key, pod is the value. These are the two labels that are currently present here. So now if I want to add a label using the imperative method, I will write kubectl label pods. Now let's write the pod name test pod, and after that give a key and value. So the key would be, let's say, key 1, and the value would be key value 1. Alright, so if I click on this, as you can see that the test pod is labeled. So if I want to check it again, as you can see that the class, environment, and the key 1 and value 1 is assigned to this test pod, and it is currently running. So now this is working fine. After that, the next command is going to be, let's say, what are these commands? Kubectl get pods l -l key and value. So basically it will give you the list of pods that are having the specified key and value. So if you want to filter the pods according to the label, you can use this command. So currently I have two pods, test pod and the previous pod that I have created, node labels. So if I want to filter the data or filter the pods according to the labels, I can use this command. So let's write this command kubectl get pods. Alright, and after that write -l, and let's give a key. So the key is environment, and it is equal to development. Similarly, this key and value is also present in the test pod. So these two labels, this label is common in these two pods. So let's write this common label here, developments. So now it will show me these two pods. Why? Because the label is common in both of them. So if I write clear, let's clear it, and if I write, let's say, key 1 and value 1, key 1 and value 1, so it will only show me one pod. Why? Because the key 1 and value 1 is present in the test pod, but it is not present in another pod. So this is how you can use this command. So kubectl, the next command is going to be kubectl get pods -l label key is not equal to label value. So it will give you the list of pods that are not having the specified value. Alright, so if this key and value is not present, it will give you all the values except this key, this label. Alright, so it will give you all the values, all the else values except this label. So let's take a look. First of all, kubectl get pods, and after that show labels, and let's check it out. As you can see that currently there are two pods, kubectl and get pods -l, and let's write class pods, class is not equal to pods. So basically this class pod is only specific to this test pod. Alright, so after it will only print the first one. Why? Because it will not print this one. It is already mentioned. So if this key value is not equal to this one, then it will print all the else values, all the exceptional values. So let's click on this. As you can see that this node label is printed and this test pod is ignored. Alright, so if I write, let's say environment and it equals to development. Right? So now it will give me all these values. Why? Because this value, environment and development, is mentioned in both of the pods. So currently, so get pods is not equal to, it will give you the list of pods that are not having. Alright, so basically it will show me all the values that are not having this value. Alright, so currently these two pods are having these labels, so it will not print any one of them. But if it prints, if it has any one of the value, then it will print the exceptional value. Otherwise, if the common label is present in all of them and you mentioned the common label, then it will not show any of the pod. So this is the point that you need to keep in mind. After that, the next command is kubectl delete. So if you want to delete a pod, write kubectl delete pod -l key is not equal to value. So basically it will delete the pod based on the labels. So if this key is not equal to the labels, then it will delete the exceptional value. It won't delete the pods that are specified. So it will not specify that this label, it will not delete this value, except it will delete all the values. So if I write kubectl, let's say get pods show labels. I want to delete this node labels. So how can I do this? I will write kubectl delete pod -l and I will write label. I will write class pod is not equal to pods. Alright, I have mentioned this. So it will skip this pod and it will delete this one. Why? Because this class is equal to pod is not mentioned in the first one. So let's click on this. So as you can see that the node label is deleted now. Alright, so after that let's take a look. As you can see that this is currently terminating, so it will take some time. So let's clear this. Let's take a look at other things, that unlike name and UIDs, labels do not provide uniqueness. Alright, so this is the thing that you need to keep in mind, that the labels are not something that is unique. As in general, we can expect many objects to clarify the same label. Alright, so many objects can use the same label, so it is not something that is unique. So once labels are attached to an object, we would need filters to narrow down, and these are called the label selectors. Alright, so if you want to narrow down and filter it, you will use the label selectors. The API currently supports two types of selectors, equality based selector and set based selector. So these are the two selectors through which you can filter the labels. So the equality based selector is based on the equal and non-equal, and the set based selector is based on the in, not in, exist. Alright, so let's take a look at the label at the pods that I have deleted. So currently, as you can see, that one pod is remaining. Now let's look at these commands. So kubectl get pods -l key is equal to value will find the pod according to the given key and value. I have shown it in the previous command. As you can see, get pods -l key is equal to value. So get pods is -l is equal to key is not equal to value. So this is the same command that I have used previously. So let's jump into the set based selector. So now kubectl get pods -l key in these values. Alright, so there are multiple values, so it will find all the ports relevant to the specified keys and values. So if there are multiple ports and each of the port has some kind of common values, then it will find all the ports according to this key value. So currently I have only one port, but let me just show you that how does it work. So kubectl get ports -l, and after that let's write the class, right? Class ports and class in let's say ports, and the next value is going to be development, right? So if one value is equal to this class, then it will print that value. Alright, so let's write the comma. I have forgotten here. So if I click on this, as you can see that only one value port is equal to this class, and it has printed that port. Alright, so if only one value is also find it, if it has found only one single value, then it will also fetch that port and show you. So kubectl get ports -l key value not in. So let's write this command also, not in. So what it will do, it will basically show you nothing. Why? Because it will ignore all those ports that do not contain these values. Alright, so if it does not contain these values, so it will show you those ports. So kubectl get ports, that is not, and this class is not in ports and developments. So although the class is present in the ports, but it has the command that not in present. So if it is not present, then it will show me. So if it is present, then it will show me. If it is not present, then it will not show me. So currently it has the command not in, so it is not showing me the ports. So I hope you understood. Now let's move to the node selector. So node selector, basically generally the scheduler will do a reasonable placement to place a port to any random node. Alright, so the scheduler will place a port to any node, but if you want to place a port to any specific node, you can do this with the help of node selector. Alright, but you can specify the port to run on a specific node based on a label. With the help of label, you can specify the port and the node, and it will they will be attached together, and the port will run in a node. Alright, so how it will do this? You can do this with the help of labels. Basically, you will mention the label inside the node, and you will mention the same label inside the port. So in this way, both labels will be matched, and after that they will be connected together. Once the node is labeled, you can use the label selector to specify the ports to run on a specific node. Alright, so you can run on a specific node with the help of labeled once the node is labeled. So you will have to label the node also. You can use label to tag nodes. Alright, so if you want to tag nodes with the help of ports, you can use the labels. So first give a label to the node. So basically I have given a label to the node already. How you can see this? Let's check it out. kubectl get nodes. Instead of writing ports, I will write get nodes. After that, write show labels. So as you can see that currently the node has many labels. Alright, these are the labels that the Minikube node is currently having. So I have already assigned this label to the node. Alright, so how you can assign this? It is the same process as I have shown you in the previous command, that if you want to assign a value, if you want to assign a label to the port, you can similarly assign a label to the node also. So here is the label. As you can see, hardware is equal to T2 medium. Alright, so I will mention this T2 medium label in the port also. So if these both labels are matched, then they will be running. Otherwise, then they will be pending. So let me show you. Let's clear this. And I have written this code in the file also. As you can see that this is the file. Just keep in mind. Let's write ls. So this is the file pod2.yml. Let's check it out. Cat pod2.yml file. As you can see that the T2 medium is currently having. So this is the kind, the pod, the API version, the nodes that are present inside the metadata, and the name of the pod, the name of the pod and the label. Alright, so after that, this is the container, and inside this container they are having the echo message, and after that there is one node selector that is present here, and the node selector has a key and value hardware that is equal to T2 medium. Now this file is going to be assigned to the pod. Alright, so how can I assign this? Simple. I will write kubectl apply f pod2.yml. Now this node labels is created, but if I take a look at this, get pods and write show labels, let's write show labels also. You can see that the node labels is running. Why? Because the node label has found the key value inside the node also. Alright, the hardware is equal to T2 medium is also found in the node. Alright, so if it was not found there, it will be giving us a message pending. Alright, so that's why it is running here. So now let's move to the these are the commands that I need to show you. kubectl, let's run this command. So basically you have understood that what the node selector does. So basically it will match the labels both on the node and the pod sides. So pod node labels, so this is the pod, will give you the kubectl describe pod node labels will give you the information of a node. Alright, so kubectl get pods. Let's copy this, and after copying, let's write kubectl describe pod, and after that paste it. Sorry, I have written the pods instead of pod. So let's click on this. As you can see that currently I have this data of that is present inside the node. Alright, so this is the namespace, this is a priority, this is the name, and these are all the data. This is the image that is currently running inside this node, and after that these are the status, initialized, ready, type state. Alright, and as you can see these are the events. So successfully assigned default labels to Minikube, pulling image Ubuntu, successfully pulled image in Ubuntu in these seconds, created container, started container. Alright, so let me find out this labels. These are the labels. As you can see, node selector is equal to hardware is equal to T2 medium. Alright, so these are the selector that has these are the label that is present inside the node. Alright, and the status is running. So this is fine. Let's clear this, and after that kubectl will give a label to the node, and the pod will be assigned to that node due to the label. So with the help of this command, kubectl label nodes, node name key is equal to value. So it will give a label to the node. If you want to give a value to the node, you will write this command. Alright, so I have already given the value to the node. You can give the value to the node with the help of this command. kubectl label nodes and give the node name. My node name is Minikube, and write the key and value. Key is the hardware, value is the T2 medium, and the pod will be assigned to that node due to the label. kubectl get pod will show you the pods that are running. So these are the commands that I have shown you. After that, the next point is the scaling and replication. By default, Kubernetes does not provide scaling and replication feature. Alright, but we do have the object that gives us this kind of functionality. Alright, so by default, Kubernetes does not provide this kind of functionality. We will have to use some objects to avail this functionality. The old pod won't restart after termination. Alright, so this is the thing that you need to keep in mind, and this is very important point, that if any pod is deleted or terminated, this pod will not restart again. Instead, a new pod will be created with the same features of the previous pod. Alright, all the data that the previous pod is containing, that data will be given to the new pod. Alright, but the IP address of the pod will be different because the new pod is created. Kubernetes is designed to orchestrate multiple containers and replication. Need for multiple containers replication helps us with reliability, load balancing, and scaling. So these are the features of multiple containers, running multiple containers and replication. So what is reliability? If one pod is failed, then another will be automatically created to make the process reliable. Alright, so let's say in an application, if one pod is crashed or one pod is terminated, then another pod will be automatically created to smooth the process. So load balancing is that if one node is overloaded, then the remaining pods will be transferred to another node to balance the load. Alright, so it will not allow one node to be overloaded. Instead, the pods will be transferred to another node to balance the load. If a movie is played, scaling, let's give you an example that if a movie is played and many users came, then an application requires more containers to manage an application. Alright, so in the starting point, many people are logging into an application. So in this case, many containers are required to run an application. So in this case, Kubernetes will automatically create those containers, and if the movie came to an end and the users are gone, then the Kubernetes will delete those containers automatically. Alright, so it will create the nodes instances if required, so that other pods are adjusted there. Alright, so now let's move to the replication controller. A replication controller is an object that enables you to create multiple pods. Alright, so it's an object that will enable you to create multiple pods so that the pod always exists. Alright, so if you get replicas is equal to 2 and one pod is crashed, then it will automatically create a new pod. Why? Because the replica is equal to 2. So in this way, if one node is failed or crashed, then by giving this value equal to 2, it will create another pod also. Alright. Similarly, if you have given the replica is equal to 3 or 5, so it will create 3 or 5 or 10 pods if one pod is crashed. Alright, so then it will automatically create a new pod and maintain the state of the pod equal to 2, 5, 6, 7, any number if you want. So if a pod is created using RC or replication controller, then it will automatically replace other pods if they crashed, failed, or terminated. Alright, so this will replace other pods, and instead by replacing those pods, it will create another pods. Alright, so I have shown you this point in the above slide. After that, it is not a default object for Kubernetes. As I have shown you that this is not a default object, you have to manually create it, write it yourself in your YAML file. So RC should be minimum set to 1 or 2, alright, so that a copy is always present. If you set this to 1, then a copy will not be present. In this case, if the replica is equal to 1, that if a pod is crashed, then it will be crashed and it will be present there. But if you set this to equal to 2, then the copy of that pod will be present. So if this pod is crashed, then another copy will be automatically created. And you can extend the number of it also. Alright. So now let's take a look at this example. This is the kind. In the previous slide we have, in the previous template, I have shown you that the kind is equal to pod, but in this time, this is the replication controller. It creates an object of replication type. Alright, so this is the object that you need to mention in the YAML file because it is not by default present in the Kubernetes. API version is equal to v1, metadata is equal to, this is the name of the pod, specifications. So specification is the replicas 2. Replica basically it defines the desired number of pods. So what are the desired numbers? Basically these are the desired numbers, and the current number and the desired number should be equal, otherwise the pod will not be able to run. These are the selectors. So selector, it watches the labels. So Bilal, this watches the selector. Template, it defines a template to launch a new pod. Alright, so inside the template there is a metadata and the name of the pod, pod 2, and after that label, the above selector value needs to be matched with this value. Alright, so this is the value, and my name, it watches the label. So these two should be similar. After that, the specifications, container, Ubuntu image, command. Alright, so now let's move to the, let's first of all copy this, because I have not copied it and I have not created a file. So let's copy this, Control C, and after that let's delegate a pod, write vi pod replica, let's say replica.yaml. After that press I, paste it here. As you can see, the data is present here, and then what you should do, you will simply write, click on the escape button, hyphen W, semicolon QA. So now if I write replica.yaml, you can see the data that is present inside this file. And if I write ls, you will see that the replica file is created. Alright, so now let's run this command that is present inside inside this file. So the first command is to apply this kubectl apply f replica YAML. Sorry, error parsing, error converting to YAML to JSON, line 8 mapping values are. So what is where is the line 8? So it is done now. Let's take a look at this, whether it is correctly working or not. Let's write, click on the escape colon W colon QA. So after that, let's clear this and write kubectl apply f and then write replica.yaml. Alright, so it is giving me another error that replication in version VI cannot be handled as replication controller, strict denying. Alright, so where is the problem? So let's take a look. So as you can see that it is currently applied. Why? Because there was an indentation problem. As you can see here that my name should be printed here after 2 spaces. Alright, should be written after 2 spaces, but I have written in the same line. And similarly, after containers, the name, image, command should be written after 2 lines. But it is currently written on the same line that it is present on the same line is present on the containers. Alright. So as the line of container is written, the image, the name is currently written on the same line here by the same spaces. So this was the problem of indentation. So you just need to keep in mind to give the proper indentation to this file. I will update this, but you just need to see this, that currently the replication controller replica is created. In the previous applying of the pods, you were seeing that the pod was created, but in this case the replica is created. Alright, so if I take a look at this kubectl get pods, you will see that currently there are 2 pods created. Why? Because I have set the replica is equal to 2. So if this replica is deleted, instead of deleting if this pod is deleted, it will automatically create another pod. Why? Because the replica is set is equal to 2. So it will maintain the desired state and the current state. So let's take a look at this. kubectl get rc. If you take a look, you will see that the replica is by the name of my replica, and these are the pods that are currently present in the inside the port. These are the ports that are currently present inside the my replica. This is the desired state and this is the current state. Both are ready. All right. After that, let's clear this and write kubectl describe rc. Replica name is replica, my replica, and as you can see that these are the details of the my replica that I have printed. So currently there are two ports that, as you can see, successfully create, and this is the message. And after that, these are the commands. This is the my name Bilal. You need to know that both of the my name should be equal to Bilal, or both the names should be equal to a single string. So these are the current state and desired state. Both are equal. So two are running, 0 waiting, 0 succeeded, 0 failed. All right. So let's clear this, and now let's run another command, kubectl get ports. We have seen replica 2. If you delete any port by writing kubectl port name, another one will be created. So let's take a look at this. Kubectl get ports. As you can see, you just need to keep this port name in mind. So after that, I will delete kubectl delete any port. Let's delete this first one. All right. As you can see that this port is deleted. All right. So let's run the kubectl get ports command again. As you can see that 4C is terminating. All right. 458 J6 is currently terminating, but the this port is created. It was 4 minutes ago, and this new port is equal to 10 seconds ago. So if I run this again, as you can see that this port is terminated, and this port is currently new created, and this was the previous one. So this is the replication. Similarly, if you want to scale up and scale down, means increase the number of replicas, how you can do this? You can scale up with the help of kubectl scale, and replicas is equal to 5 rc l, and now the name of the my name is equal to Bilal. All right, label name, let's take a look at this label name. First of all, kubectl get ports, show labels. There is one hyphen missing. All right, so this is my name, and that is equal to Bilal. You need to keep in mind that this my name should be equal to, both of the names should be equal to 1. So let's copy this. After that, let's write kubectl scale replicas is equal to, let's say, 5. All right, and write rc hyphen l and my name. Let's copy this, my name, and these two labels and the ports that are relevant to these labels will increase the number of replicas. So currently there are 2 replicas, there are 2 ports, but after running this command, the number of ports will be increased. So let's click on this. As you can see that the my replica is scaled. So if I write, let's say, kubectl get ports show label, as you can see that currently there are 5 ports that are created. So let's wait for some time and run it again, because it is currently creating. Alright, so all the ports are currently running. Alright, and these are the ports, the 1, 2, 3, 4, 5. Alright, so these are the ports that are created, and through this command we can scale up the number of replicas. And if you want to scale down the number of replicas, how you can do this? You will simply write the command, let's say, equal to 2. Alright, so now the data will be the same. You just need to change the number of it. Let's click on this, and after that, let's clear this. show the number of ports. As you can see that these ports are terminating except these two ones. Alright, so let's wait for some time and it will terminate all the ports except these two ones. It is still terminating, so no problem. So now let's take a look at the replica set. So the replica set is the advanced version of the replication controller. The replication controller only supports equality-based selectors like replicas is equal to 2 or replicas is equal to 3, 5, 6. But whereas the replica set supports both equality-based and set-based selectors. Alright, so we have discussed what is equality-based and set-based. So set-based is basically multiple values inside are under one key. Alright, so set-based are basically multiple values are equal to just one key. But in the equality-based, one key is equal to one value. One value is equal to one key. Alright, so this is the difference between equality-based selector and set-based selectors. So here is an example. Alright, so let's take this template and copy it. As you can see that in the kind we have written the replica set instead of replication controller, and in the API version we have written apps v1. This is my RS means replica set. These are the replica sets, and after that these are the match expressions. The key is my name, operator in, values Bilal and Khan, means there are two values equal to this one key. Similarly, there is one key and one value. So these are the data that is present inside the replica set template. This is the template, and this is the test port 4. This is my name. This is the specification which contains the containers. So let's write the vi replica set .yaml. So after that write I, and after that let's copy the data here, and let's move the cursor above and let's delete this data here. Alright, after that press escape -w -qa. Now if I take a look at this replica set.yaml, you can see that the data is present here. After that, let's run the kubectl. First of all, let's apply it. Applying, how you can apply this? kubectl apply f replica set.yaml. This does not create. Alright, so here is a problem. Replica set. What is the problem here? So replica set. Sorry, maybe here is the naming problem. Alright, the name is the replica cast. I have written the replica cast instead of replica set. So this is the problem. Alright. So now if I click on this, as you can see that replica set.apps myRS created. So let's take a look. kubectl get pods. As you can see that these two containers are created. Alright, and the previous containers which I have terminated, the previous pods which I have terminated, 3 of them are deleted now and 2 of them are currently running. Alright, and the new containers, the new pods are created. So after creating the pod, delete it and you will see another pod automatically created. Alright, so let's clear this and write again. Here is the error pull image. This one is not pulled. So what is the problem here? Let's take a look at this. It is pulling back off. Alright, currently it is running. Alright, so it is now working fine. After that, let's first of all show them, and as you can see that they are running, but delete, let's say delete one of them. myRS copy and kubectl delete pod and the pod name. Alright, so let's remember the pod name JWT7G. Now this port is deleted. Alright, so let's clear this and write now kubectl get ports. As you can see that JWT7G is terminating, and the new port, that is the L7BBR, is now created. This is 13 seconds ago. So this is running fine. And after that, kubectl describe, let's write kubectl describe rs replica set name. Replica set name is the let's write this one. Sorry. What is the replica set name? Let's find it here. My rs. Alright. kubectl describe rs my rs. As you can see that currently there are 3 ports that the normal successfully created. This new one is created 63 seconds ago, and this was the new one, and the previous one was deleted. And 2 of them are running. All right, the previous one was that. This one was deleted, and now these 2 ports are running, and the first one was deleted. So these 2 are running, and current state is equal to desired state, no waiting, no succeeded, 0, and all of them are running fine. So there is no error. Alright, let's clear it. And now if I want to scale up and scale down, you can also do this by writing kubectl scale replicas to this is 2, let's write it 3. Alright, rs my rs. Now if I write it, click on this, sorry, there is a scaling problem. Alright, I misspelled it. Now it is scaled. kubectl get ports. You can see that currently there are 3 ports running. This is the newly created port. If I want to scale it down, I can also do this. But as you can see that in this case, in the replication controller or the replica set, the ports were, if we create a port, if we delete a port, another port will be automatically created. But if I want to get rid of these ports and don't want to run the replication controller or the replica set, how can I do this? I will instead delete this replica delete rs my rs. Alright, so let's write kubectl delete rs my rs. Now this rs is completely deleted. Let's take a look at this. 3 of them are terminating. And the similar case with this replication control also. If I want to delete them, how can I do this? Let's take a look at this. You can't delete the replica port because it will automatically create a new port. Instead, you have to delete the file by typing kubectl file name. Alright. So where was the file? It was, let's take a look, replica. Alright. So let's delete it. But if I let's take a look at this replica kubectl delete f and the replica. Now this file is deleted. If I write kubectl get ports, you can see that these 2 replication controller ports are also terminating. So now it is working fine. Let's take a look. It is still terminating. It is not terminated, but it will terminate soon. So these are the things that I have discussed in this video. I hope you like this video. So if you have any questions regarding this video, regarding this labels and selectors, you can ask me in the comment section below. I'll be happy to answer all of them. So till then, goodbye.